Alright, so we have our finished design. Definitely not the most complicated of circuits like some of the ones I've showed you guys, but as you can see, it took a lot of work to get here. And of course, as you get more familiar with the tools, you can build things a lot faster, a lot more beautiful, and a lot more complicated. Alright, so we're gonna do a couple things. The first thing I want to show you guys is how to see how our design looks through OSH Park. So let's go to our web browser. We were at OSH Park earlier, but you can just type OSH Park, which stands for Open Source Hardware Park, or you can type it into Google. I'm sure it'll come up as one of the first results. So we get to our purple site, go back to our board, make sure we save. Don't have to worry about saving. You can save on either the schematic or the board. It'll save both of them automatically. And then we go browse for files. And what we need to give to OSH Park is documents, EAGLE projects, or wherever you saved it. Most of the time I don't actually use the projects folder. And then our board, the BRD file, not the schematic. If you do the schematic, it'll yell at you and say that it needs a board, or it'll just yell at you. So select the board. It's going to take a moment processing. Pretty much what it's probably doing is breaking our board up into the Gerber files that it needs to actually manufacture on OSH Park side, and also to show us this interesting preview that we're seeing a little bit now and in a second. So one thing I want to point out is it tells us it detects a 2-layer board, which is good. That's what we designed. It tells us the size, 1.1 inch or 28 millimeters, which makes sense. At first it was a 30 millimeter design, then I made it a little bit smaller to fit. The board name, we can give it a description. So sometimes I call it revision number 1, and I'll show you guys how to make silk screen in just a moment. Gives us any notes. Everything looks good. It's all green. Sometimes it'll give you yellow if you don't have like silk screen on the bottom, and that's okay. If it gives you something red, you may need to ask their support or Google what's wrong with your board. You should log in if you haven't, or make an account. You don't have to. It may have you like put in your email or something if you're not logged in. Click continue, and then pretty much what it's going to show you is some really good information to help debug your design if there's any problems. So the first thing it shows is board top. This is what OSH Park quote unquote guarantees what your board will look like. So here, if you notice this dark purple and then light purple, this light purple is our ground plane, and you can see here the connections that we saw on the board and the connection it has with pin 4, which is the ground of the AT Tiny. Shows the silk screen and the name. Notice it doesn't show the values. It doesn't appear by default. You'll have to change the layers of it, but usually people don't print out the values. It shows the bottom of the board, so apparently what OSH Park guarantees the bottom of the board will look like. We need to pay close attention. It may be hard. See how this is protruding through our device. It won't affect us in this case, but you have to be careful in your design. Actually, it might be bad. The battery might be making contact with these pins and cause a short circuit. It probably won't work very well that way, but just be aware for your design. You need to know what you're doing. And the silk screen, this is the drills from the top layer perspective. So here we have drill hole for the switch, and then hole here on all these through hole pads, and those correspond to this. We have the bottom solder mask, and then the bottom layer silk screen. So this is just like isolated view of just what gets printed on your board. This is the top layer. This is where actually all the copper will be poured, or all our conductors, and you'll notice these should be our routes, and then you can see the ground plane once again. The board outline always looks kind of boring unless you do an interesting shape, but it'll show pretty much the outline of the board and any holes that we have. Top silk screen. So again, this is just all the top quote unquote writing that's on top of the board, or art, and you can do some really fancy stuff like the logos. Top solder mask, and then bottom layer copper. So again, all the things we can solder to, and the power planes and our signals. Cool. So if you wanted to, you can go ahead and order now. I don't recommend ordering this board, but just to show you the full process, OSH Park sells things in sets of 3. So you have to order 3. So it's $6 for 3 of them. So it's about $2 each. It's kind of expensive for a relatively boring board. But if you want to order more, you do them in sets of 3. You can also choose some of their different services. I'm not going to talk much about them, but just be aware that you can do some interesting services if you want to order more, or have some special thinner boards or faster service. Pretty much they'll get it to you in less than 2 weeks. Cool. So that's pretty much it for our board for ordering it. Again, what you can use here previously is if you see any mistakes, this is a great debugging tool. Where something looks funny, like I just noticed that this looked terrible and that it might cause a problem, then you can go back to your board and make the appropriate fix. So for example, I just use the group tool, and then you can highlight a bunch of stuff. Again, it goes by the origin, but also gets the dimension layer and the polygons. I'm going to do move. To move a group of things, you do the group like I just showed, highlight what you want. Then you select the tool that you want to use, and then you right click and go to move group. Kind of a weird thing in EAGLE, but it's just how they operate. Definitely kind of bizarre and unintuitive. So unfortunately, I should have actually chosen, and we could have, this to be a surface mount device, and then we wouldn't have had the problem that I was just showing you guys. And in fact, let's just do that right now, because that would make our board much more expensive if I had to make it this big. And let's actually show that. So we make it this large. I'm going to save. You guys don't have to do this. We'll go back to OSH Park, go to the main site, browse for files. Since I saved the board, make sure you have to save it. it. If you don't, then it'll show the same one we just did. Open it, and while that's loading, let's go back and make these changes. So I'm going to Control Z back, and then I'm going to go to the schematic because you can't actually affect any of these parts in the board. So go to the schematic, and I'm going to type in replace. So this is a new command, and because I already know I'm going to add an ATtiny85, I want to put AT for ATtiny, and I could put most of the words, but I have to be careful because I'm not exactly sure what I named this device. I want to put AT because I know it has AT in it, star, and it'll show me all the AT devices, and we added an ATtiny X5 or ATtiny 85, so I'd have to type out this whole name if I wanted to get it without putting the wildcard. And let's do the surface mount one, and then click on here. So nothing really changed. I guess I had a different value here that changed it for me. And if we come back here, notice how it has been changed. Unfortunately, some of our stuff got shifted around. You guys don't have to make these changes. I'm just showing a point, but I will show you guys just to make it look pretty. Rip all the wires, route 6 mil. I'm going to route 10 mil to here, and then I'll finish this connection as we had before. There we are. We can move the LEDs closer. I want to highlight the wires here too. Move, and we can see we can move it closer like that. While we're at it, let's move the LEDs up. So this is just to show you guys when you're designing your board if you need to make any large changes. And heck, we could probably even make the whole board smaller, but we'll leave it as is. So notice how we actually have to make the connection to ground now. I want to make use of our ground planes here. So I'm going to do top and then bottom, and then I want to make this mighty close here. And what this will do is make our connection to the bottom. So when I type in rat's nest, it makes the connection for me, and it's right there. Cool. So let's go back to see what our design looked like. So notice how the price went from $6.05 to $7.55, and it changed the size. And we can go ahead and look at that, but instead I am going to send up our new one, which will be exactly the same, except that we change this to a service mount pad or a service mount device. All right, so it's really very similar. Rev 1, continue. Everything looks fine. Notice less drill holes because we're not using a through hole component. And this time when I look at the top here, this is on the top, this is on the bottom. There's going to be no interference. This looks close, but since I've designed with these components before, I know this actually won't interfere or make any unnecessary contact. This is fine because this is connected to ground anyways. So one thing we got to do before we finish our design, we got to add some swag on there. So let's add some text. And to add text, you just type in text, and you can put whatever you want to call your board. So I'm going to call it Learning Eagle. But notice if I type enter now, it'll put on the bottom layer, and I want it to be on the top of the board. And to do that, we put it on T place. If you want on the bottom of the board, then you put B place. And we'll put something on the bottom too to show an example. So I'm going to put on the top of the board, oh shoot, I guess I got to retype it, text Learning Eagle. And you can select the size, so maybe 1.5 millimeters. The ratio changes the thickness. I like to put the name of my board as 20 ratio, so it makes it kind of thick. The font should be vector. Sometimes it won't print out well if you don't have it a vector font. The alignment shows where the origin is. I'm going to leave it where it is, and that's fine. And this looks good. Careful if you put it like, over a device, then you probably won't be able to see it once you solder it. But I can put it pretty much anywhere because this is all on the bottom. So I think wherever I had it was fine. And then, like I said, I like to put the revision of my board. So I'll put it on the bottom. So I'll put text Rev 1. This one I want it to be a little bit smaller. The ratio I can leave as 20%, that's fine. And notice how this is on T place. I'm going to go ahead and put it right here on the board. And then I'm going to do mirror. And notice when I do that, it's mirrored, and that if I go to info, it's now on the bottom of the board. So I'm going to do this flip board, and now it looks meaningful to me. Like this is how it'll actually print on the bottom side of the board. And we can put it right here. It won't actually interfere with our Learning Eagle because it's on different layers. So it's going to look weird now, but I just want to show you guys that I can put it over this text, which will not actually affect anything. So one last time, let's go ahead and throw it over to OSH Park. Browse, make sure to save it. I don't know if I saved it. There we are. Learning Eagle. Give it a second. While we're waiting, I want to show you guys something. You may not be able to do this because as of now, Eagle and Fusion don't have the support for letting us share 3D models, which is kind of dumb. It's through some web app interface that is kind of silly, but in the future, they promise that we'll be able to share libraries. So hopefully I'll have another video where this is updated or you guys will be able to share it. But anyways, so you want to go to Fusion, create new design. You could in Fusion make your board and then do this interesting syncing around, but I'm not going to talk about Fusion too much here because this is an Eagle tutorial. You should be logged in with your account, and I already have several projects on there. I'm going to put this in random or play. It tells us the ones we have 3D packages for, and so we have 3D packages for everything. If it didn't, they would come out as a red sheet. We can give a comment, so this is like first board push to Fusion, and this is just a note for yourself, kind of like if you're familiar with Git. Go ahead and do push, and that'll take a while. So meanwhile, we'll go back here. So again, back to $6.05 because we're back at the 28 millimeter Rev 1 to match our Rev 1 here. If I actually sent this out and maybe there was a problem or I upgraded the design, then I would change this to Rev 2 and change it on there respectively. So at the top of the board, we have our Learning Eagle, and then on the bottom of the board, we have our Rev 1. You can also put some fancy art, which maybe we'll show in a different tutorial. And again, we can go ahead and order the board, but I'm not going to do that. So that's all I'm going to show you guys for OSH Park. It says our board has been pushed to Fusion, so let's go ahead and check it out. You guys might not be able to do this. This is just to show you guys the 3D models. If you do have Fusion, just be aware that you might not be able to see the 3D models as of now. Hopefully in the future. Otherwise, we'll show in another video on how to make your own parts and how to actually be able to view your own stuff. All right, so it's going to take a second for Fusion to open. Computer's kind of slow, plus I have the recording software. Alright, so this is Fusion. All I'm going to say is it's a 3D modeling suite. Play, and here you see some of my crummy designs of things. We see our Learning Eagle board, so if we double click on that, we could change the color. If we go back to Eagle here, if you go to manufacturing, you can change the color to whatever you want. So if we go to solder mask and change it to purple, this is the OSH Park purple color. In order to actually see the changes, we have to repush the Fusion. I'm not going to do that. I'm just going to show you what it looks like as green. But here is our device, and so this should be exactly what we saw when we planned it. There's our AT Tiny. Again, it doesn't show the values for anything. There's our capacitor, LED, resistor, even our connections, our ground plane. I don't think it makes it visible on purpose, but that's fine. And we flip it over, there's our battery connector. This is where we'd insert the battery. Unfortunately, our model doesn't show the battery, but that's not that important. And then it has our switch. So hopefully that's really cool. You can even see a 3D model. So if I hadn't seen it when I uploaded the OSH Park, but our through hole, I probably would have seen it poking out here, and then I would have been a little bit worried that it may have actually made contact with our battery and thus short-circuited some of our components, which probably could have been bad. But hopefully that's rad. Unfortunately, the rest of our board here on the top isn't very exciting, and so, you know, maybe sending this out wouldn't be the best use of our money. But hopefully you guys see the idea that that's really cool and a really powerful feature of both Eagle, Fusion, and just the Autodesk suite in general. So hopefully you guys enjoyed this. This concludes the Eagle tutorial, and I hope you guys are able to play around with it. Unfortunately, I couldn't show you guys some super advanced stuff, but stay tuned. We will have more videos on some more advanced features and going into more detailed stuff. And we have several projects where we utilize Eagle, and you guys can also learn from that. So thank you. Hope you guys enjoyed it, and I'll catch you nerds later.